Okay, so today we have more practice with linear, exponential, discrete, and continuous domain. So we're going to identify if something's a word problem is linear, exponential, continuous, discrete. We're going to write the equations, which we've done before, so this should not be new, and rewriting the domain from a word problem. So remember, percent is always going to be multiplied, which means it's going to be exponential. And then if you have an increasing percent, that means you take 100 plus that percent. If it's a decreasing percent, you take 100 minus that percent. And then you just change those to decimals, and that's what you multiply by. So what I want you to do is I want you guys to read this first problem here, and I want you to answer some questions for me. All right, so we start off with 1 because we got the first box with 15 books. Then it says we get donations, and on average each box contains 8. So we're going to add 8 because that means on the second box then we're going to have 23 books now. When we get our third box, we'll have 31. When we get our fourth box, we'll have 39. So it's discrete because we count the number of books in each box, and it's linear because we're adding by 8, and we're going to end up having a straight line graph. So when we graph this, first things first, boxes is going to be our X, books is going to be our Y. So that's how we get our labels on our graph. Boxes at the bottom, books on the side. So you're going to do your best to graph it. So we got 1 and 15, that's easy. Then we have 2 and 23, you got to guess. 3 and 31 is about right here. 4 and 39 is about right there. And again, it's going to be a straight line, but we don't connect these because we said it was discrete. Now, when we write out our domain, remember domain is all X values. So we have 1, 2, 3, 4, and I'm going to write that out, and then so on. And I'm going to put 3 dots here to show that it's going to continue. It's not going to end, right? Because you keep getting donations. That doesn't stop. So that's how we're going to show if something like keeps continuing. And that's more of like if we have word problems. So that's going to be the little bit of new stuff. Okay, so now we're going to write the explicit equation. So we've done this before, so this should not be new. So we get y equals 8 times x minus 1 plus 15. How we used to write that was y equals 15, what we started with, plus what we're doing down our table, 8, and then our variable, and then the opposite of what we started with for the x next to our variable. So that this is not new. This way is written a little bit different, but this is not. Okay, so now it's going to ask us what's going to be after 10 boxes. So you can use the explicit or you can extend the table. Extending the table would be pretty easy here, but I'm going to use the explicit. So I'm going to rewrite this equation, but with instead of an x, because boxes is x, I'm going to write a 10 because it says 10 boxes. So this is my equation now. Now what I want you to do is I want you to type this into your calculator, or you can extend your table, but tell me what you get when you get to the 10 boxes, or if you use this equation. All right, so you should have gotten 87 books. So after 10 boxes, we're gonna have 87 books. So the next problem now is about Miss Rolfe giving her son some medicine. So I want you to read through that, answer some questions for me, and then we'll go through it. So when I first give my son medicine, it's 60 milligrams. So no time has passed when I give my son medicine. So that's gonna be a time 0. And then we started with the 60 milligrams, okay? However, medicine is leaving his body at 20% per hour. So that's where we have to use that information that we wrote out at the beginning of the class, the decrease right there, leaving his body is a decrease thing. So I do a decrease percent. So I do 100% minus that 20%. That gives me 80%. I'm going to change that to a decimal. So that gives me 0.80. Remember, decimals you always multiply. So that's why we're multiplying by 0.8 as we go down our table. All right. So this is continuous because we measure medicine leaving the body, and it's exponential because we're multiplying by 0.8, and we'll have a curved graph. Okay, so when we graph this, hours is going to be our x, and milligrams is going to be our y. So here's my table. Hours is my x-axis, milligrams is my y-axis. So I have 0.60, then we have 1.48. So again, you're going to have to do your best guesses here. We got 1 and 48. Then we have 2 and 38.4. So that's like right there. And then we have 3 and 30.72, so that's going to be about here. Now we know this graph is continuous and it's exponential, which means it's going to curve. So we know it's going to be connected and curving. However, see how I end here with an arrow? That's because the medicine will keep leaving his body until it's all the way gone. So that's why we have to put an arrow down here, because it's not going to end. Which leads into our domain. Our domain, we started with a closed dot at 0, and then we have a right arrow. So that's where we write squiggly 0, mouth with the line, X, open mouth with an infinity symbol. That infinity symbol is because of this arrow. So the next thing we're going to do is write the explicit. So that means if we are multiplying and it's exponential, we're going to have an exponent in our explicit. So we have y equals 60 times 0.8 to the x. Okay, start with 60, we're multiplying by 0.8, and it's just an x because we started at time 0. Now again, it's going to ask you 10 hours. And in this time, you can use the explicit, or you can extend this table until you get to 10 hours, but it's going to be a lot of decimals. It's going to be easier to just use the explicit. So I'm going to rewrite this equation, but instead of an x, I'm going to use a 10 because our x values was talking about hours, so 10 is going to replace this x. So when I do that, here's how the equation gets written out. What you want to do is write or type 60 times 0.80 to the exponent 10 into your calculator. And remember, in your calculator, this is the exponent button. All right, hopefully you got something along the lines of y equals 6.442 milligrams. If you need more notes, we're going to do some together. If not, go ahead and do your exit ticket and get that party started on your homework.